Okay, on this next video, we're just going to practice using all the different rules or different rules for differentiation that we've talked about in the past. So, free to use any of the previous ones to be able to identify when to use product, when to use quotient, when should I use chain rule, and our trig functions as well. So let's just get some practice here. So the derivative of our e to the x function is just going to be what? E to the x, but we also have, because that's a u in this case, so it's e to u times the derivative of u. So we also have to accommodate for the derivative of what's in our exponent there. So remember doing this a previous lesson. What is the derivative of 5x? Just 5, so basically we're going to have 5e to the 5x. And by this point, you can pretty much go straight from there, but I want to see this step, so practice that. So even if it's a little more complicated, our exponent, okay, we're going to have that similar rule. So y prime is just going to be what? We have e to the u times the derivative of u. In this case, we have the derivative of our parenthesis. What is the derivative of this term? Negative 7. Good. Careful with your sign. So we just get y prime is equal to negative 7e to the 2 minus 7x. Okay. Y equals xe to the 3x. What's the first thing you need to identify? That this is two terms. I like to denote that by doing this because it reminds myself that it's two terms, and therefore I know that I need to do what? Product rule, which is first times the derivative of second plus second times the derivative of the first. So if you will, go ahead and work on that. Okay, the next step we're going to do is actually evaluate the derivative here and evaluate the derivative here. Okay, so here, just simplifying this step, what's the derivative of 3x? 3, so we just have 3e to the 3x here. So if you'll let me simplify that, I'm just going to have x times 3e to the 3x plus e to the 3x times 1, which is just this. Okay. Now, they do have something in common. If we just wanted to algebraically manipulate this a little bit, what if we pulled out a GCF? E to the 3x, what would we be left here with this term? Good, a 3x plus 1 is a placeholder. Good. Okay. What do you think? Quotient rule. We can use quotient rule. We could actually move this to the top and have x to the negative 1, but then that's a power rule and a chain rule inside of there. So we'll just go ahead and go with the quotient rule here. They seem to be pretty basic terms, and our exponential functions are fairly easy to evaluate the derivative. So we're going to go ahead and go with the quotient rule. So set this up. Low d high minus high d low over the square of what's below. Okay, so we have that set up first. Now we're going to actually, in our numerator, we're going to take the derivative of this term, and we're going to take the derivative of this term. That'll be our next step. Okay, next we're going to simplify this derivative in blue. What's the derivative of 10x? 10, so this is just going to be 10e to the 10x. Alright, and they do have a common term. What would it be? E to the 10x, so just simplifying algebraically, if we pulled out an e to the 10x as our common term, what will we have left? A 10x minus 1 is a placeholder all over x squared. Okay, so here we have two terms. Oh, well, this is one term plus this term over here involves two terms, so I like to denote that here. So we'll take the derivative of this term and the derivative of this. But what about this guy over here? What will we have to do? Product rule, right? First times derivative of second plus second times derivative of the first. Let's go ahead and set that up. Taking the derivative of this first term is represented here. To simplify it, I'm just going to take the derivative of 2x. And for this one, we got to do product rule, first times derivative of second plus second times derivative of first. Let's go ahead and start evaluating derivatives in this next step. Okay, so we're going to simplify here. Okay, we stop here. We simplify. That's as far as we can simplify in this case. Because e to the x is not the same as e to the negative x term, so there's no GCF term in that one. And actually, this e to the negative x here is carrying it down. I left off the negative, so go ahead and make sure you didn't do the same thing. Alright, next we're going to work with a higher order derivative. We're just going to find the second derivative this time. So take the derivative, get that answer, then take the derivative of that to get the second derivative. Okay, so we apply our rule here. We take the derivative of this term, and what's this going to be? Good, just a 7. Okay, so this is, we have successfully reached our first derivative. Now we need to differentiate again to find the second derivative. So we'll do, apply the rule again, and we'll get 9 times 70. It's going to be 630 to the what power? 8th power times the derivative of 7x plus 3, derivative of what's in our parenthesis. Okay, go ahead and simplify that and simplify your second derivative. Okay, so we've finished with 4,410 times 7x plus 3 to the 8th power. Okay, so we have a new function. This is e to the x squared plus 9x. Find the second derivative. So go ahead and pause it. Take your time to do this. And find your first derivative, then take that answer and find the second derivative. Okay, do a check on your first derivative first. Make sure you have it. Now within the first derivative, and when we take this derivative again, we have product rule right there. So first times derivative of second plus second times derivative of first, and then we have the derivative of this term. So go ahead and evaluate that derivative. Okay, check your answer on that. Okay, so we have, we're obviously going to have a product rule also with a chain rule. So first times derivative of the second plus second times derivative of the first. Let's establish that part first. Okay, the next step, we're going to take the derivative of these terms and simplify that. Okay, so we would have 4, 3z minus 1 to the 3rd power times the derivative of this. And then for this one in red, we're going to establish that. Let's go ahead and evaluate these and simplify. Okay, we are just going to stop right here with this one. To be able to have time to get through all the examples we want to look at, we're not going to try to pull out GCFs right now. So just go ahead and simplify that right there. Although we know they have a common term of a 2z plus 5, what, to the 2nd power, a 6. They also have 3z minus 1 to the 3rd power. Just so you see it with GCFs pulled out.